4.2 seconds. That's how long one endpoint took to return a list of orders. Not a report, not an export, a list. Support tickets were stacking up. The app feels broken, nothing loads. I clicked twice and got charged twice. Nothing was down. Everything was just slow. And slow, at scale, is the same thing as broken. This is how I took that endpoint from 4.2 seconds to 84 milliseconds. 50 times faster. No new database, no caching layer, no rewrite in a faster language, just profiling, one query plan, and 3 changes. I'll show you the exact tools I used, in the order I used them, so you can run this on your own slow endpoint tonight. First rule of performance work: a complaint is not a measurement. Users said the app is slow. That could mean the network, the front-end render, the API, the database, or all 4. So before touching code, I opened the browser network tab and sorted by time. One request stood out: get/API/orders. 4,200 milliseconds server time. Everything else was under 100. Now I have a target. Wrong turn number 1. I assumed it was the database being overloaded, so I looked at CPU. 30%. Memory, fine. Disk, fine. The database was bored. That's the tell most people miss. A bored database serving slow requests doesn't mean it's healthy. It means you're asking it the wrong questions, over and over, and waiting on round trips. 25 minutes gone before I stopped guessing. Here's where I stop guessing and start measuring. Python, so I reach for cProfile, wrap the handler, hit the endpoint once, sort by cumulative time, and the output is brutal. 411 calls to the database driver's execute method. 411 for one page of 50 orders. I didn't write 400 queries. The ORM wrote them for me, one at a time, while I wasn't looking. This is the N+1. One query to fetch 50 orders, then for every single order, a lazy query for its customer. Then another for its line items. 50 times 2, plus the original, plus a few extras. Each one takes maybe 8 milliseconds. Individually invisible, together 3.1 seconds of pure round-trip latency. The database is fast. The conversation with it is slow. Then I take the one remaining slow query, the main orders query, and run, explain, analyze on it. Read query plans from the inside out. Deepest node first. And there it is. Sequential scan on orders. Rows removed by filter, 1.8 million. 900 milliseconds. I'm filtering on status and created at, and there's no index that covers that combination. Postgres is reading the entire table to hand me 50 rows. 3 changes. 1. Kill the N+1. Eager load the relations in a single query with a join, 411 queries down to 3. 2. Add a composite index on status and created at descending, built concurrently so it doesn't lock the table. Sequential scan becomes an index scan. 900 milliseconds becomes 4. 3. Stop selecting every column. The endpoint returned 42 fields, and the UI rendered 9. That third one surprised me. After the query fixes, I was at 310 milliseconds, and I thought I was done. I profiled again, always profile again, and the top entry was no longer the database. It was serialization, converting fat objects into JSON, including a description field averaging 4 kilobytes that nobody displayed. Select only what you render. 310 milliseconds became 84. Final numbers: 4,200 milliseconds to 84. 411 queries to 3. Payload, 1.9 megabytes to 61 kilobytes. Same database, same server, same framework. And here's the part that matters. The endpoint didn't just get faster for one user. It stopped hogging connections, so every other endpoint got faster too. Slow code is a tax everything else pays. Here's the lesson. Performance work fails when you optimize the thing you already suspect. Your intuition points at the code you remember writing. The profiler points at the code that's actually running. Those are almost never the same place. I have never once guessed the bottleneck correctly in 10 years. Not once. Measure, fix the top item, measure again. That loop is the entire skill. The mental model I use now. 1. Find the slowest endpoint before you optimize any function, network tab, or your APM, sorted by time. 2. Profile the request, don't read the code. cProfile in Python, the node inspector in JavaScript, explain, analyze for the database. 3. Count the round trips before you tune any single query. N plus 1 beats a bad index almost every time. 4. Reprofile after every fix because the bottleneck moves. 1 endpoint, 3 changes. 50 times faster in an afternoon. Code that works and code that scales are two different pieces of code, and the gap between them is almost never cleverness. It's visibility. Profiling is just the practice of looking at what's really happening instead of what you assume is happening. Everything else follows from that. If this changed how you approach slow code, follow for more engineering stories from production. Run a profiler on your slowest endpoint tonight and drop the number of database queries you find in the comments. I'll bet it's higher than you think. See you in the next one. The